BYD just put a battery into a luxury car that weighs more than a full-grown man riding a motorcycle. Over 700 kilograms. More than 30% of the entire car's weight is battery. And here's the part that should stop you. It's built from the cheap, boring chemistry the entire Western auto industry spent a decade calling second-rate. Yet it charges 400 kilometers of range in 5 minutes, drives past 1,000 on one charge, and you can drive a nail straight through it and it won't catch fire. Almost nobody outside China understands how they actually pulled this off. Let me show you. Every battery does one job. It shuttles tiny charged particles, lithium ions, from one side to the other. Move them one way, you're charging. Move them back, you're driving. That's the whole magic. Now here's the problem the industry lived with for years. To store a lot of energy, most companies used a recipe packed with nickel and cobalt. Great for range, terrible temper. Puncture it or overheat it, and it does something called thermal runaway. In plain English, it catches fire, and it does not stop. The safer recipe was sitting right there the whole time. It's called LFP, lithium-ion phosphate. Cheap, stable. It shrugs off abuse that would make a nickel battery explode, and it lasts for thousands of charge cycles without complaining. But it had one humiliating weakness. It was heavy and low on energy, so cars using it had short range. For years, LFP was the reliable minivan of batteries. Safe, boring, nobody's dream car, and Western automakers happily left it to the budget end of the market. BYD looked at that trade-off and asked a completely different question. Everyone else was trying to fix LFP's weakness by messing with the chemistry, chasing new elements to boost the energy. BYD asked instead, what if the chemistry was fine and the real waste was in the shape? That's the Blade Battery. They took the safe LFP recipe and rebuilt the cell into a long, flat blade, almost a meter long. Then they packed these blades side by side, like slices in a loaf of bread, straight into the floor of the car. Old batteries were cans packed inside boxes packed inside a crate. Wasted space everywhere. BYD threw out the boxes and just filled the whole crate with battery. Same safe chemistry, far more of it in the same space. That single idea put a safe battery into a car that actually goes the distance. And that was just the warm-up. Now the nuance, because the simple version hides the genuinely brilliant part. When you make a cell long and flat like a blade, something useful happens to heat. If a short circuit starts, the heat has a huge surface area to escape from and a long, thin path to travel. It spreads out and cools instead of concentrating and igniting. That's why in the nail penetration test, the one engineers call the Everest of battery safety, the blade cell's surface stayed between 30 and 60 degrees Celsius. A conventional nickel cell in the same test blew past 500 and burst into flames in seconds. Same nail, same lab, wildly different outcomes. There's a deeper physics reason too. When a nickel cell overheats, its chemistry starts releasing its own oxygen, which is like handing a fire its own fuel. LFP simply doesn't do that. It holds its oxygen tight, so even a badly injured cell has nothing extra to burn. But BYD wasn't finished, and here's where it gets clever. Those blades aren't just batteries, they're also beams. Packed edge to edge across the floor, the pack becomes a structural part of the car's frame. They call it cell to body. The battery holds the car up. Let that sink in, because it's a 2-for-1 Western engineers mostly failed to pull off. In a normal EV, the battery is dead weight the frame has to carry. In a BYD, the battery is the frame. You delete the separate structure, save weight, free up space, and fill that space with more blades. More blades means more range. And the strength this adds is not a small thing. BYD has publicly driven a 46-ton truck straight over a blade pack, and it held. In the second generation, They crushed it with 400 kilonewtons of force and scraped the underbody at 70 kilometers an hour, both to China's tough new national standard, and it still refused to burn. A battery that doubles as a crash structure makes the whole car stiffer and safer at the same time. That kind of compounding win only shows up when you design the battery and the car as one object, not two. So the first generation Blade, back in 2020, already solved the impossible problem. It gave LFP's bulletproof safety a range that could compete. And because LFP skips expensive cobalt and nickel, BYD could build cheaper, safer cars than almost anyone. Now, March 2026, the second generation Blade. This is the one chasing 1,000 kilometers. And to get there, BYD changed three things at once. First, the cathode. They swapped standard LFP for LMFP, adding manganese to the recipe. That's the M. Manganese lets the cell run at a higher voltage, packing more energy into every gram. Energy density jumped from around 140 watt-hours per kilogram to roughly 190 to 210. That leap is what makes 1,000 kilometers realistic. Second, the anode. They moved from plain graphite to a silicon-carbon blend. Silicon holds far more lithium than graphite, so it stores more energy and accepts a charge faster. Though silicon is tricky because it swells as it fills, which is part of why nobody rushed to use it until the engineering caught up. Third, the electrolyte, the fluid the ions swim through. BYD used AI to tune a flash flow electrolyte that cuts internal resistance by roughly half. Less resistance means less heat, and less heat means you can push enormous current without cooking the cell. Higher voltage cathode, higher capacity anode, faster electrolyte, all three working together. None of them is a magic new discovery on its own. The magic is stacking them at once in the same cell and getting them to cooperate. Combine all three and you unlock the number that made the whole industry stop and stare. So what does all that engineering buy you? Start with the number drivers care about most: charging time. BYD's second-gen Blade adds 400 kilometers of range in 5 minutes, 10% to 70% in that same window. It runs at 10 developed Celsius, an incredibly aggressive charge rate through a flash charger delivering around 1,500 kilowatts. A good Western fast charger tops out near 350. Here's why that's a real feat, not just a bigger cable. Shove that much energy in that fast, and the number one killer is lithium plating, where lithium metal builds up on the anode and permanently wrecks the cell. BYD's answer is a self-repairing protective film on the anode, engineered at the molecular level, that survives the stress of 10 developed cells charging and heals itself even under that extreme load. And this isn't just a lab claim anymore. In July 2026, BYD ran the flash system in Europe and pulled a car from 10 to 70% in 5 minutes and 20 seconds on real roads outside China. The number survived contact with the real world, which is exactly the test most battery hype quietly fails. Then there's lifespan, which quietly changes the economics. BYD rates the Blade for over 3,000 charge cycles, roughly 1.2 million kilometers before it wears out. For years, the fear was that fast charging slowly murders a battery. You could fast charge this one hard for the whole life of the car and not come close. Now the range, brought to life by BYD's newest flagship, the Great Han, debuting at the Chengdu Auto Show this August. It's rated at 1,008 kilometers, and it gets there by carrying that 102 kilowatt-hour pack from our opening, the one weighing over 700 kilograms. Think about that for a second. BYD is now putting a battery the size of a small motorcycle into a luxury sedan, safely, using the chemistry everyone once dismissed. Be honest with the number, because I always will be. It's measured on China's CLTC cycle, which is gentle, more forgiving than the American or European standards. Real world is more like 500 to 600 miles. But even the honest figure is far past what any driver needs in a day. And the more mainstream CATL 08, at a confirmed 905 kilometers, shows this isn't the halo card trick. It's spreading across the whole lineup. And cold weather? The thing every winter EV owner dreads. Winter can gut your range and slow charging to a crawl, and it's the single biggest reason people in cold climates hesitate to go electric. BYD claims that even after a full day sitting at minus 30 degrees, this battery still recharges from 20 to 97% in about 12 minutes. And why stop at 97? Because BYD's engineers leave that last 3% empty on purpose, as headroom to capture energy from regenerative braking. That's the kind of detail you only sweat once you've already solved the hard problems. Now zoom out, because this stops being about one car and becomes about the balance of an entire industry. In the first 5 months of 2026, Chinese companies held over 72% of the global EV battery market. 7 of the world's top 10 battery makers are Chinese. The IEA says China produced over 80% of the world's battery cells in 2025. Read those numbers again, because they describe a level of dominance the world doesn't have in almost any other strategic technology. This isn't one lucky product. It's a whole supply chain. China controls the mining, the refining, the chemistry, the cells, and the cars. When BYD wanted the Blade Battery, it didn't have to ask anyone for the manganese, the iron, the factory, or the chargers. It already owned every link. And they're building the roads for it too. Over 1,500 kilowatt flash stations were up by early 2026, with a target of 20,000 by year end. Each one carries its own battery buffer that sips grid power slowly, then dumps it into your car in a burst, so the grid never buckles. Which brings us to the uncomfortable truth underneath all this brilliant engineering. Here's what nobody outside the industry really talks about. The Blade Battery isn't a miracle of new chemistry. LFP was invented decades ago, partly by American researchers. Manganese cathodes, silicon anodes, none of it is secret. The ingredients were on the shelf for everyone. So the breakthrough wasn't discovery, it was integration. BYD's genius was refusing to accept the trade-off everyone else treated as a law of nature, then out-engineering the packaging, the manufacturing, and the supply chain until the trade-off simply vanished. Sit with this, because it reframes everything. For 20 years, the West bet on the chemistry. More nickel, more cobalt, more energy per cell. And it accepted the fire risk and the cost as the price of progress. BYD bet on the system. Take a humble, safe, cheap chemistry and win by engineering everything around it better than anyone else. BYD's founder, Wang Tuanfu, started out making cheap phone batteries by hand, beating Japanese giants with clever process engineering instead of expensive automation. Decades later, he's running the same playbook on the car industry. Don't win the science fair, win the factory. And here's the proof he's winning. BYD's single biggest problem right now isn't demand or technology. It's that they physically cannot build these batteries fast enough. Their own chairman calls it a happy problem. Customers stuck in delivery queues so long that BYD now hands out free flash charging for every day an order runs late. When your bottleneck is that the world wants your product faster than any factory on Earth can make it, you've already won the argument. You cannot outspend this with a subsidy. You cannot fully tariff around it because the cost advantage is baked into a supply chain that took 20 years and a national strategy to build. When BYD skips cobalt and nickel, it steps around the exact minerals Western supply chains fight and negotiate over. And when these cars reach Europe and Latin America, industry analysts expect them to undercut comparable European models by anywhere from 30 to 50%. That is not a gap a rival closes in a product cycle or two. It's a structural lead. And it's not even one company. BYD's rival CATL unveiled its own 6-minute charging LFP battery in the same window. Two Chinese giants pushing each other so hard that the whole world's timeline for better batteries is now set inside China on Chinese terms. By the time a Western or Korean maker reverse engineers this year's cell, next year's is already in production. There's a quiet irony worth naming here. For years, LFP was dismissed in the West as the cheap, low-end chemistry, the one you'd never put in a premium car. BYD took that inferior technology and, through pure engineering discipline, turned it into the battery that now sits in a 1,000-kilometer luxury flagship. The technology everyone underestimated became the technology everyone's chasing. Let me be fair, because this channel doesn't do hype. The 1,000-kilometer numbers use China's gentle cycle. The 5-minute charge needs BYD's own chargers, not the plug in your garage. And any new chemistry needs years on the road before we truly know how it ages. But strip all that away, and here's what remains. A safe battery, a cheap battery, and a long-range battery used to be 3 different cars. BYD put all 3 into one, not by discovering something new, but by understanding, better than anyone, how to build. So back to where we started. That battery heavier than a man on a motorcycle, built from the boring chemistry everyone wrote off. BYD didn't break the laws of physics. Physics still works. What they broke was the assumption that the trade-off had to live inside the chemistry. They moved the problem to the shape, the structure, and the supply chain, and solved it there. And that tells you where the next decade is heading. The winners might not be the ones who discover the cleverest science, but the ones who master the brutal, unglamorous work of building it at scale, cheaply, safely, 1,000,000 times over. So here's my question. Is this the moment the West lost the battery race for good? Or the wake-up call that finally starts it? Tell me in the comments. And if you want to understand how China is quietly winning the technology war, one industry at a time, subscribe, because that's the whole reason this channel exists. See you in the next one.